Okay, so I will be recording this so you guys can have it available to you later. Before spring break, we covered graphing standard form quadratic equations. What's a quadratic? It's anything with an x squared in it. So like a quadratic trinomial would be y equals x squared minus 2x plus, I don't know, anything, plus 5, right? So that is a parabola right there. There's a standard form quadratic trinomial equation. We should be able to recognize that it has the a value of 1, the b value of -2, and the c value of 5. And just to review what we learned in the past, we should know, I want to take a picture of the wall right here, that the most important point of a parabola is the vertex. So you always first find the vertex. The vertex is a coordinate. And how do you find that coordinate? You find it with the formula x equals -b over 2a. And again, where do you get those b and a values from? It's simply the number in front of x, that's the b value. If there is no x, then your b value is 0. And the a value is always the leading coefficient, the number out in front of the x squared, okay? And if you're closer to the other wall, it's even nicer. It's printed out on the other wall. So on the other wall, what is a standard form? We just wrote it, y equals ax squared plus bx plus c. That's up here, standard form quadratic trinomial. We know that these quadratic functions, anything with an x squared, produces a u-shaped curve that we call the parabola, okay? And on the wall, it says that this point right here is the vertex. I don't know, you can't really see that, it's a bad picture. And also through the vertex exists a dotted line that I always do in green. It's called the axis of symmetry. That's what it says right there, axis of symmetry. And the axis of symmetry is always x equals whatever the x value is of your vertex, okay? So it has it on the wall. How do you find the vertex? Again, the vertex is a coordinate. You're going to use the formula x equals -b over 2a. And when you use that formula, replace the b with parentheses and the a with parentheses. And once you identify the b and the a, plug it in right there and right there. And then that will give you the x value. X equals whatever this equals. And once you have that x value, then you plug it in to your actual original equation to find the y value of your vertex. And that will be the most important point. And once you have that most important point, the vertex, then you'll be able to state your axis of symmetry, which is simply x equals the x value of your vertex, which is the same thing as the formula x equals -b over 2a. And once you have the vertex and the axis of symmetry, you could find more points by using an input-output table, right? By plugging in numbers for x and getting out answers for y. Or you could use the pattern when your a value is 1 from the vertex. Or you could also use the modified pattern, which we'll talk about later, okay? So this is all a review from before spring break. We actually worked on this worksheet before spring break. I know a lot of you couldn't find it right now, so you got a blank one. So let's just go to this parent graph, y equals x squared, and let's graph this the old school way by doing an input-output table, an xy table. And we're going to use consecutive integer inputs like -3, -2, -1, 0, 1, 2, 3. Technically, on an input-output table, you could use any numbers you want. And again, the numbers that are on the left side are your x values, and that's why they're called the inputs, because you're going to plug them in right in here. And then you're going to do the math, and it's going to say y equals whatever that answer is. So if I plug in a 0, when I plug in a 0, 0 squared is 0. 0 times 0 is 0. When I plug in a 1, 1 squared, 1 times 1 is 1. When I plug in a 2, 2 squared, 2 times 2 is 4. When I plug in a 3, 3 squared, 3 times 3 is 9. Again, I'm just taking the 3, plugging it in, and 3 times itself is 9. Okay? And if you go in the negative direction, -1 right here in parentheses, -1 squared, -1 times -1 is +1. -2 times -2 is +4, and -3 times -3 is +9. And when you graph these, you'll see, let's start with the 0, 0, that's right there. Then we're going to go to 1, 1, that's 1 on the x, 1 on the y, that's right there. Then you go to 2, 4, 2 on the x, 4 on the y, that's right there. And the last one, 3, 9, 3, 9, it'd be up here, right? 3 on the x, 9 on the y. You could also go -1, 1, and if you do go -1, 1, you end up over here. Now, as you can see, that is going to be a perfect mirror image reflected across the axis of symmetry. The axis of symmetry, I always do it as a green dotted line, and it crosses right through the vertex. And you'll see that that distance is 1, so the distance over here is 1. So you don't actually have to go to the coordinate like negative 2, 4, which is negative 2, 4. It's right here. You could simply reflect it over the other side, and you'll get to that same location, negative 2, 4. Or this location up here, which would be the negative 3, 9, right? But anyways, there's your parabola. Let's just draw it. Now, it doesn't stop at the x value of 3. It continues to go forever. Like the next number 4, if you plugged in a 4, 4 squared is 16. So you could do 4 and then 16, but what's the point of that? Because 416 is off the graph, right? 416 is off the graph. So that's why I didn't do 416, even though it does exist. So 416, you're not going to graph it, but it's there. It does exist off the graph. It could be 525, 636, could be 749, 7 squared is 49. So the parabola really does go to the left and to the right forever, right? It's just, if you go one more this way, if you go 4, you're going to be at 16. If you go 5, you're going to be at 25. If you go 6, you're going to be at 36. You're going to be really off the graph. So, but it's important to understand that it does go to the left and to the right forever, which means that the domain is x equals all real numbers because it goes to the left and to the right forever, okay? The range value are your y values. And if you think about the y-axis, which is up and down, like up here is the y value of 10, down here is the y value of negative 10. If I asked you for where the graph exists in terms of y values, does it exist at the y value of negative 10? Heck no. Does it exist at negative 5? Heck no. Does it exist at negative 1? No. Where does it start existing on the y's? At 0 and above. So how do we say that this parabola exists at the y value of 0 and above? You would say y is greater than or equal to 0. Yay? Okay. What else could we say? We could also mention the y-intercept. Y-intercept. I hope we remember that the x-intercept is the location of where the graph crosses the x-axis. The y-intercept is the location of where the graph crosses the y-axis. And how do we find the y-intercept? You simply set x equal to 0 and solve. But you could visually see where it crosses the y-axis. It crosses right there at the location 0, 0. Okay? But anytime that you don't have a graph and they ask you find the y-intercept, all you have to do is set x equal to 0 and solve. Okay? Now, over here, we did set x equal to 0. And when we set x equal to 0, 0 squared is 0. So 0, 0 happens to be the vertex, and it happens to be the y-intercept as well. Again, if you're writing this down for the first time, this guy right here is the most important point. Let me do it in red. I'm sorry. That's called the vertex. Vertex. That guy right there. It's either the highest point or the lowest point of the parabola. Okay, so this is graphing by using an input-output table, but we're supposed to get more comfortable with standard form quadratic trinomials, and once we do get comfortable with it, we'll know what the a value does to the parabola. And we did cover this before break. If the a value is positive, the parabola will open up. If the a value is negative, the parabola will open down. Okay? Let's actually take a look at, you know what, let's just jump to this first graph right here. Okay? Now, some of us already have this written down from before break, but those of us that got a new copy, let's go to it right now. So step 1 to graph any parabola is to find the vertex. Vertex, which is a coordinate. How do you find that coordinate? Obviously with the vertex formula. The vertex formula is x equals negative b over 2 times a. And when you use the formula, as it's shown on the picture on the wall, you replace the b and the a with parentheses. So instead of negative b, you put negative parentheses. Instead of over 2 times a, you put over 2 times parentheses. Then you go back to your actual function and identify that this is your a value, this is your b value, and the c value is not in the formula you don't really care about. This is a, this is b. So you're plugging in the b value of 6 and the a value of negative 3, and you do the math. Up on top, negative 6 is negative 6. On the bottom, 2 times negative 3 is also negative 6. And whenever you have negative 6 divided by negative 6, that's a positive 1. So we just found out that x equals positive 1. Now, what x? We're talking about the x of the vertex. That's positive 1. Okay. So once you have the x to any equation and you want the y, how do you do that? You simply plug it in. You're going to plug what in? You're going to plug in the x value of 1. Where? Into your x's. X equals 1. Take those x's and put a 1 in place of the x's. So you're going to go back and rewrite it. Y equals negative 3x squared plus 6x plus 5. Okay? Notice that I put parentheses instead of x's. Why? Because I know that x equals 1. So I'm going to take that 1 and put it in that parenthesis and in that parenthesis. A 1 right here and a 1 right there. And then you do the math. You could type this in exactly the way it looks into your calculator, and it'll give you your answer, which is the y value of your vertex. Or you could do it by hand, thinking of PEMDAS. Starting with parentheses, there's nothing to do inside the parentheses. You move on to e exponents. 1 squared, 1 times 1 is 1, but you still have the multiplication of negative 3 in front. And over here, you still have the 6 times 1, and you still have the plus 5. Then you move on, after exponents, you move on to multiplication, which is right there and right here. So multiply next. Negative 3 times 1 is negative 3. 6 times 1 is 6. And you bring down the plus 5 at the very end, add or subtract. So if you go negative 3 plus 6, that's 3, and 3 plus 5, that is 8. That is the y value of your vertex. So that's the most important point. That is the hardest part of graphing a parabola, finding the vertex. By the way, the last week before spring break, we had several assignments on graphing parabolas. That first assignment was just find the vertex. So I gave you an equation, and I say find the vertex. This is the math you have to do. Anyways, when you're graphing, this is the most important point. We're going to graph it now. Let's go to the location 1, 8. So 1 on the x, 8 on the y. Put a dot right there. That is the vertex, 1, 8. Once you have your vertex, the easiest thing to do next is to draw a dotted vertical line right through that vertex. That's called the axis of symmetry. And that's going to simply be, since it's a vertical line, in order for an equation to produce a vertical line, it has to be x equals a number. And obviously, in this case, x equals the x value of your vertex, which happens to be 1. So this is an actual question that you're going to have on the next quiz or test. I could ask you find the vertex of this equation. I could ask you find the axis of symmetry, which would be x equals 1 of this equation. But right here we're graphing, right? So we found the vertex. We drew the axis of symmetry. We need more points. Now, if the a value was positive 1, then it would be exactly the same width as this parent graph, okay? Because the a value will tell you if it opens up, if it's positive, down if it's negative, and if it's further away from 0, it gets vertically stretched. If it's closer to 0, it gets vertically compressed. So it does tell you if it's wider or narrower. So whenever you have the a value of 1, in this case, the a value is 1. In this case, the b value is a number in front of x, which there is no x, so it'd be 0x. And in this case, the c value would be nothing because there is no b or there is no c. But anyways, when you find your vertex and you draw your axis of symmetry, if your a value is 1, you're going to be able to use the pattern 1, 1, back to the vertex, 2, 4, back to the vertex, 3, 9, and then map it over to the other side, and you'll have your parabola if your a value is 1. But right here, the a value is not 1, okay? So there's two options. One option is to modify your pattern according to your new a value, okay? So if a equals 1, then you could use the pattern, you could use pattern 1, 1, 2, 4, 3, 9 from the vertex. But if you have a new a value, in this case the a value of negative 3, you're going to have to modify it. So modify by a being negative 3. So how do you do that? You simply go to your outputs, the outputs of your pattern, and you multiply these all by whatever that new a value is. So since the a value is negative 3, we're going to have to multiply the 1, the 4, and the 9 by negative 3. So you're just going to go times negative 3, times negative 3, times negative 3. And so instead of 1, 1, you're going to have 1, and what's that? That's negative 3. So you're going to have 1, negative 3. And then the next one, instead of 2, 4, it's going to be 2, negative 12. And then the next one, instead of 3, 9, it's going to be 3, negative 27. So here's the deal, guys. This is what we call a new modified pattern. 1 to the side, 3 down. Then you go back to your vertex. 2 to the side, 12 down. Then you go back to your vertex. 3 to the side, 27 down. Okay? So that's what we could do to graph this thing. And that's what we're going to do. Check it out. So from the vertex, I'm going to go, instead of 1 over 1 up, if the a value was 1, I'd go 1 over 1 up and put a dot right here. But it's not a value of 1. It's an a value of negative 3. So I'm going to go 1 over and 3 down. So 1 over and 1, 2, 3 down, and I'm going to put a dot right here. Everybody please put a dot right there. And then you go back to the vertex, and you're going to go 2 over and 12 down. So 2 over, 1, 2, 12 down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You're going to put a dot right there. Is that right? Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, dang. 12 would be down here. My bad. 1 less. What do I do about that coat? Or that one? Let me just white it out. Okay. And of course, you could map them over to the other side. So if this guy is 1 unit away, just go 1 unit this way, and you'll be able to find that point mapped over right there. This next one is 2 units away, so go 2 units this way and put that dot right there. And voila, we have graphed. There's my parabola. And we haven't done this yet. This is the first time you ever see this, modifying the pattern 1, 1, 2, 4, 3, 9 to get more points. Now, did you have to modify the pattern? I think that's the easiest way of graphing. By the way, the last part of the pattern we didn't use, 3 over, 27 down. If you go 3 over and 27 down, you're going to be way off this graph. That's why we didn't even bother with it. But the other alternative is to actually do inputs and outputs, right? You could actually, so instead of the modified pattern, you could be like, or input, output. So by XY table. Now, I love the pattern, the 1, 1, 2, 4, 3, 9. I asked you to memorize that pattern. It's even right here in the notes. A pattern for a parabola with the a value of 1 is 1, 1, 2, 4, 3, 9. Now, if it's not an a value of 1, if it's an a value of, like, let's say negative 3, then all you got to do is write down that pattern, 1, 1, 2, 4, 3, 9, and change the outputs, the 1, the 4, and the 9, change them by multiplying by whatever this new a value is. If this would have been a positive 2, you'd be multiplying these guys by positive 2 instead of negative 3. If this would have been an 8, you'd multiply these guys by 8 instead of a negative 3. So you just modify the outputs of your pattern by the new a value. What do you think? Okay. So that's a good question. What if your a value is negative 1? Well, you could multiply these guys by the 1, 4, 9 by negative 1. Or you could just be like, oh, the pattern 1, 1, 1, 1, 2, 4, 3, 9 still exists, but because it's negative, you're going to be going 1 over 1 down, 2 over 4 down, 3 over 9 down, right? But obviously, you could show this work and actually multiply them out, and it'd be 1, negative 1, which is 1 over 1 down. It'd be 2, negative 4, 2 over 4 down, 3, negative 9, if you multiplied everything by negative 1. So yeah, by whatever your a value is, if it's not 1, you could modify your pattern and then use that pattern, or you could go back to an old school XY table. Now, what do I mean by old school XY table? Plug in any numbers you want. Now, if you plugged in, like, let's say a 5, that would be ridiculous. Because a 5, check it out, here's 0, 1, 2, 3, 4, 5. That's going to be way the heck off the graph. So you're going to have to pick x values that are close to the x value of your vertex. So don't pick 1 itself. You could pick 2 or 3, or you could pick 0 or negative 1, totally up to you. But if you did plug in a 1, that's not going to save you any time or help you, because you already know that when you plug in a 1, you get out an 8. That's what we did over here with the vertex 1, 8. So if you plug in a 2, and do the math, see, here's the problem. You got to do a lot of math. 2 squared is 4. 4 times negative 3 is negative 12. Negative 12. Did I do this right? I'm confused. Let me use a calculator. So even if you use a calculator, it's going to take a while. All I did was plug in the input 2 right in here into the original As you can see, -3, parenthesis, there it is. I plugged in the 2, close parenthesis squared, plus 6, open parenthesis, plug in the 2, plus 5 at the very end. Hit enter, it'll give you a 5. So 2, 5, the input 2 gave you the output 5. And if you went to the graph, 2 and 5, you'd get to that point right there. So obviously, even with the calculator, it's going to take you way longer because you still have to do that with the number 3 and so on and so on. So even with the calculator, you take way longer than understanding the pattern 1, 1, 2, 4, 3, 9, writing it down, and then modifying it by whatever your new A value is. So the pattern is the quickest, most efficient way of graphing these by hand, okay? Now, if we went to this one at the bottom, this one has the A value of what? Of 1. So right there, we are going to be able to use the pattern 1, 1, 2, 4, 3, 9 because the A value equals 1, right? The A value is 1. But you don't start with the pattern, you start with the vertex. And once you have the vertex, then you could use the pattern from the vertex. So everybody should write down the vertex is a coordinate. How do you find that coordinate? It's x equals -b over 2 times a. When you use it, please write it with parentheses, -b over 2 times parentheses. Plug in the b value. Now, remember that the b value is the number in front of x. Now, we have an x squared right here, but do we have a regular x? No. So the b value is not -3. That is the c value, the one that's by itself. So if you're confused, you might want to rewrite it and be like, okay, 1x squared plus there is no x term, and then a -3 at the very end. Now you could see a is 1, b is 0, c is -3. So when you plug in a 0 for b and the a value of 1, you get -0 divided by 2, and that's still 0. So x equals 0. That is your x value of your vertex. How do you find the y value? You plug it in. So you're going to rewrite your equation, y equals x squared minus 3, and when you plug in that 0, when you do the math, 0 squared is 0, and 0 minus 3 is -3, so y equals -3. So we just found the vertex y value. So let's all go to the location 0, -3, and put a dot right there. That's 0, -3. Now that's the most important point. From there, you could draw your axis of symmetry, which is kind of unnecessary because you could clearly see that it's the y-axis at this point. And you need more points. Are you going to use an XY table? If you want to, but that's really a waste of time because if your A value is 1, it says down here, when the A value is 1, you could use a pattern 1, 1, 2, 4, 3, 9. So we're going to be able to use a pattern 1, 1, 2, 4, 3, 9 from the vertex. 1 over, 1 up, put a dot right there. And you go back to the vertex and you go 2 over 4 up. So 2 over 1, 2, 3, 4 up, put a dot right there. And then we go back to the vertex and go 3 over 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And of course, you map them over to the other side of the axis of symmetry. And there's your parabola. It's pretty simple. I hope we remember this stuff. Now, on the back side, we have practice. But how about this? Before doing the practice, let's write down some really good notes in our notebooks. So this is pretty much everything that you need to know about graphing standard form quadratic functions, okay? The most important thing is finding the vertex. How do you find that vertex? You're going to use the formula x equals -b over 2a. Then plug that x value to solve for y. So plug in your x to solve for y, and you'll have your most important point. Once you have that most important point, the vertex, it's really easy to draw a green vertical dotted line right through it, and that'll be your axis of symmetry. Now the equation of the axis of symmetry is x equals whatever the x value of your vertex is. So whatever you have right here, x equals that number will be the vertical line that's called the axis of symmetry. And then from there, you could easily find the y-intercept. And in this case, the y-intercept is 0, c, only for standard form. But in reality, how do you find the y-intercept? To find y-intercept, set x equal to 0 and solve. So when I say set x equal to 0, that's where the 0 comes out in on the x, for the x value on the y-intercept. So you plug in 0, find out what y is, and it will be the c value. Again, imagine if you had a number here like 5x squared plus 4x plus 3, and I told you find the y-intercept. You plug in 0 for your x's, everything becomes 0 except whatever this number is over here. So on standard form, your y-intercept is super easy. It's 0 comma c. All you do is set your x's equal to 0, and that last number will be your answer. So 0 comma that last number c is your y-intercept, the location of where it crosses the y-axis. If your a value is 1, you're going to use the pattern 1, 1, 2, 4, 3, 9. The domain of any parabola is going to be x equals all real numbers. The range of any parabola is it's going to be y is either greater than or equal to the y value of your vertex, or y is less than or equal to the y value of your vertex. Now, let's say you don't have the a value of 1. Let's say you have the a value of 2. Well, then you could modify your pattern to a different a value. So if your a value is 2, you still write down your 1, 1, 2, 4, 3, 9 pattern, but you multiply the outputs by whatever your new a value is, in this case 2. So if your a value is 2, it's not going to be 1, 1 anymore. It's going to be 1. 1 times 2 is 2, so 1, 2. So you're going to go 1 to the side, 2 up. Then you go back to the vertex, and instead of 2, 4, it's 2 to the side and 8 up, because 4 times 2 is 8. 9 times 2 is 18, so you go back to the vertex, 3 to the side, 18 up. So that's how you modify a pattern. So this right here is truly new information. We didn't talk about this before spring break. We're talking about it right now after spring break, right? When your a value is 1, it's really simple. It's 1, 1, 2, 4, 3, 9. But when your a value is something else, like if you have a 2 out in the front, you're going to have to multiply the 1, the 4, and the 9 by that new a value of 2. Multiply them by 2 to get your new modified outputs. That way you could have your new modified pattern. Instead of 1, 1, it's 1, 2. Instead of 2, 4, it's 2, 8. Instead of 3, 9, it's 3, 18. Okay, so this whole page is super important, right? And you could always use an XY table to find more points, but if you understand how to modify a pattern, you're never going to have to use an XY table again. So at this point right here, I'm going to pause it to allow you guys to copy this down into your notebooks, right? There was, I think, 3 assignments before break that had everything to do with graphing parabolas. As a matter of fact, the first assignment was just on this, finding the vertex, right? The second assignment, I think, was finding the axis symmetry and maybe the y-intercept. And the third and final assignment was graphing using the pattern 1, 1, 2, 4, 3, 9. And on that third assignment, we only had parabolas that had a leading coefficient of 1, the a value of 1. But now, after today, after you write down these notes, you're going to know how to modify that pattern according to your new a value, okay? So jot this down. I'll pause it right now, jot it down, and that way you could use it if you're working on these assignments at home. And just to let you know, the stuff that you're writing down in your notebooks is on the wall right here. That's why I want you to write it down so you can have it in your notebook. So if you're working on it at home, it'll help you out. But here in class, it's all right here. Like even down here, look, it says when the a value is 1, use the pattern 1, 1, 2, 4, 3, 9 from the vertex, right? But what if your a value is not 1? What if your a value is any other number? Well, right next to it, it says right here, your modified pattern, if your a value is a different number, all you have to do is take the 1, 1, 2, 4, 3, 9 and multiply your output 1, your output 4, your output 9, multiply it by that new a value. That way you have your new modified pattern, okay? So everything that you're writing down in your notebook right here is on the wall, but of course, I would like you guys to jot this down in the notebook. So again, if you're watching this for the first time at home, hit pause, jot this down in your notebook, or I'm going to pause it right now and finish copying it right now in class. So let's do an example using this information. So if we go to the back side of our notes, we have practice, right? It's labeled 1, 2, 3, 4, and also 1, 2, 3, 4. I don't know why I labeled it like that, but anyway, let's pick one. Let's do one where we have to modify the pattern. Okay, so that would be like number 3 or number 4. So let's do this number 3 together right now. And again, what do we start with? Well, on the notes you just jotted down, you start with your vertex. So that's what we're going to do. We're going to begin by writing down vertex. That is a coordinate. You find the coordinate using the formula x equals negative b over 2 times a. You replace the b and the a with parentheses. That way you could use the formula easily. Once you do that with parentheses, you go to your equation and identify A, B, and C. You don't even care about C because C is not in the formula. But you're going to be able to plug in the B value of -8 right in there and the A value of 2 right there. So up on top, you end up with a -8, which is really a +8. And on the bottom, 2 times 2 is 4. 8 divided by 4 is 2. So you just found out that x equals 2. That is the x value of the vertex, 2. Now you still need the y value. Once you have the x and you want to find the y, all you got to do is plug it in. And the notes that you just jotted down say that. And also the wall says that. So let's rewrite our original quadratic equation. Y equals 2x squared minus 8x plus 5. And we are plugging in the x value of 2 into those parentheses. Now, at this point, you could type it in exactly the way it looks with parentheses and with exponents, exactly the way it looks on the calculator, and it'll give you your vertex y value. Or you could do it by hand using PEMDAS. You start with p parentheses, and there's nothing to do in here or there, but then you move on to e exponents. So you go 2 squared. What's 2 times itself? That's 4. But of course, you still have the times 2 on the front. So after doing exponents, you move on to m, PEMDAS, right? M is multiplication. So you're going to multiply here. 2 times 4 is 8. You're going to multiply here. 8 times 2 is 16, but there's a minus sign, so minus 16. And then you bring down the 5. And last but not least, just add or subtract. 8 take away 16 is -8. -8 plus 5 is -3. That's exactly right, -3. So we just found the y value. Y equals -3. That's the y value of your vertex. So let's plot that most important point. 2 on the x, -3 on the y. There it is. And then right through any vertex, the very next thing to do, as it says on the notes, is to state your axes of symmetry. And it's really easy to state it when you see it visually. That's simply that green dotted line that crosses through the x value of 2. But algebraically, it's just as easy. All you got to do is say x equals whatever the x value of your vertex is. So x equals 2. Okay, so now we're ready for more points. So yes, you could go back to the old school way of doing it and do an input-output table, right? Like a XY table. And you would have to plug in some numbers. And the numbers that you put into the x's have to be close to the vertex x value of 2. So you could plug in a 3 and a 4, or you could plug in a 1 and a 0. But when you plug in numbers, it takes a while to do it. I mean, unless you're plugging in 0, that one's really easy. That'd be finding the y-intercept, right? The y-intercept, when you plug in 0, look how easy it is. Put a 0 there and a 0 there. Everything becomes 0, and then you have the c value of 5. So that tells you where your parabola is going to cross the y-axis, 0, 5. That's way up here. So you already know what the parabola looks like, and you could map it over to the other side, and it would be over here, okay? But what I recommend is to write down the pattern. When a equals 1, your pattern's 1, 1, 2, 4, 3, 9. But obviously, the a value here is 2. The a value is 2. So when your a value is 2, you're going to take that new a value and you're going to put it times 2, times 2, times 2. You're going to modify the outputs of your original pattern, 1, 1, 2, 4, 3, 9. You're going to multiply the 1, the 4, and the 9 by that new a value of 2, thus giving you a new pattern, 2, 8, 18. So what is your new pattern? Your new pattern is 1 to the side from your vertex and 2 up. Then you go back to your vertex and you go 2 to the side, and it's no longer 2, 4, it's now 2, 8. So 2 to the side, 8 up. Then you go back to your vertex, 3 to the side, and 18 up. So let's do that. Let's go 1 to the side and 2 up. You'd be right there. You can map it over to the other side. Then you can go back to your vertex, 2 to the side, 1, 2, 8 up, 1, 2, 3, 4, 5, 6, 7, 8. You'd be right there. Map it over the other side. And if you went 3 to the side, 18 up, you're way off the graph. So we already finished. We have perfectly graphed this thing without doing much math after the vertex. This is the only challenging part. After that, if the A value is 1, you're going to use a pattern 1, 1, 2, 4, 3, 9. But if the A value is 2 or 3, multiply your outputs by whatever that new A value is, and you'll have your new modified pattern.